All right. Mechanical vibrations. Last time we learned that mechanical vibrations are governed by this master equation. Where mx double prime is really from the F equal to ma, so that's from the Newton's equation. Cx prime comes from the dash pot, so it's like friction in the system. So this is basically the damping. And Kx actually comes from the Hooke's law, which says F equals to negative Kx. And this Ft is the external force. Now let's start with the simplest of these, undamped motion. If there's no external force acting and there's no damping at all, what we have is mx double prime plus kx equal to 0. So over here, we're assuming c equal to 0 and ft also equal to 0. In such a case, the solution has the following form. Remember, all these m, c, k are positive. They can't be negative. They're physical constants. And if you write down the characteristic equation, this is mr squared plus k equal to 0. So that r squared is equal to negative k over m, which gives you r equals to plus or minus square root of k over m. Because of this negative. And therefore, your solutions are in terms of sines and cosines, right? So you know that xt has to be cosine of wt and sine of wt and c1, c2. Where this w, I should actually say omega. Omega is square root of k over m. And because this is a periodic function with the period, what's the period of this sinusoidal function? Remember, t is equals to, you learned this in physics.
1 over f.
Okay, that's 1 over f, right? But what's f?
F
Frequency.
is frequency.
Yeah, it's omega over 2 pi. That's f. Okay? Or omega is 2 pi f. Right? Okay, so you learned this in physics that this omega is called the angular frequency, and in terms of omega, the period is 2 pi over omega, and also because the period is 1 over frequency, this says that if you just do cross multiplication, you get omega equals to 2 pi f. So you can either use t equals to 2 pi over omega or omega equals to 2 pi f to figure out the frequency and the period of this swinging motion. In other words, with this much time, it will complete one entire period. So maybe I forgot to say what this motion is about. This is mechanical vibration, where you have a block attached to a spring on the wall. And because there's no damping, we're not putting the dash pot, and we're assuming that there's no friction in the system. So if you push it this way and leave it, then it's going to go swing back and forth. And because we're assuming there's no friction, it's never going to stop. It will always go back and forth without stopping. And because it's a periodic motion, all these things, the angular frequency, omega, angular frequency, and period and frequency, all these things can be applied in this system, just like where you learned this in physics. Now, if you forgot this form of t equals to 2 pi over omega, here's a quick way to think about it. If omega is 1, you get cosine of t, right? Do you remember the period of the cosine? Cosine x, what's the period?
1.
What's the period of cosine? You guys know this. Okay, so 2 pi, pi over 2, 3 pi over 2. And then the sine graph goes like this. And the cosine graph goes like that. And this thing repeats, right? So what's the period? 2 pi is the period. You knew that. You can't say you didn't know that. Okay. So when omega is 1, you have 2 pi as the period. If omega is 2, what happens to the graph? It contracts by half, right? So the period, the new period will become pi. If omega is 2, the new period will become pi. If omega is 4, it's going to be a quarter, so the new period will be pi over 2. That's why you get this formula, 2 pi over omega. And then you use this along with t equals to 1 over f, you get this, right? Okay. Now, there's another thing I want to say. If you're given some initial conditions, you will get the value of C1 and C2. Right? And often, it's instructive to figure out what this function is as a single function of cosine. So let me talk about that briefly. So interlude. If you had a times cosine omega of t plus b times sine omega of t, then you can define c as square root of a squared plus b squared, and do the following. You can pull the c out and divide both a and b by c. So these are equivalent because if you multiply the c to both of them, c's in the denominators will cancel, so these are the same thing, right? Now the advantage of having it in this form is that because a over c squared plus b over c squared is a squared plus b squared over c squared. Note that you have common denominators, so you can put them together. And what is c squared? According to our definition. A squared plus b squared. C squared is a squared plus b squared. And since you have same thing on top and bottom, you end up with 1, right? It means that this square plus that squared is 1, which means if you had a unit circle, then there, I don't know where these two values are, but if you set x as a over c and y as b over c, or a over c comma b over c, that will be a point, this comma this will be a point on this unit circle, whatever. Let's just pick any point. Where should I pick? Let's just say it's here. Okay. If you say that that's some point on the unit circle, then you can always draw a ray towards to the origin and think about this angle theta. Right? And you can say that this thing is cosine of theta, and this thing is sine of theta, for some theta. Okay? And that's the sole purpose of figuring out. Sorry, let me change the letter. Often, rather than theta, people use alpha for this. So let me use alpha. Alpha, and cosine alpha, sine alpha. So let's assume that we found such alpha. I'm actually going to provide you a formula for getting the alpha. If you have a calculator, you can just, instead of figuring out C, you can just go directly from the value of A and B. Using this formula, you can calculate alpha without having to draw this picture, okay? But I just want to show you where this alpha actually comes from. So let's assume that we do have that alpha, and here's what we have in that case. We have cosine of alpha, cosine omega t, plus sine of alpha, sine omega t. And then we can use the following formula in trigs, which is that if you have cosine A minus B, that's cosine A, cosine B, plus sine A, sine B. And that's exactly the same as this part here, right? Yeah. So I can just say C times cosine alpha minus omega t, or omega t minus alpha, it doesn't matter. You can rewrite this as alpha minus omega t, or omega t minus alpha. That's because these cosines can switch places, right? So in fact, cosine of A minus B is the same as cosine of B minus A. So I have this. So what I'm trying to say is that anytime you have something multiplied to cosine omega t and something multiplied to sine omega t, then you can put them together into a single cosine function with a new amplitude c and a new angle alpha. You'll be seeing this again when you get to your electrical engineering class, because although we are doing vibrations, the same differential equations appear again on a circuit with an inductor and a capacitor and a resistor. So this is called the Lcr circuit, LRC circuit. If you write down the equation for the current going through this system, you get exactly this type of differential equation. And often the main question is, what is the final amplitude of the current that's flowing, right? And then you also have to ask for the phase angle of the current. So sometimes the current goes faster than the input voltage, or it lags behind the input voltage by certain degrees. And that's always some concern to electrical engineers when they try to design circuitry. Okay? So that's why this form is very important. You're going to be doing this all the time in your electrical engineering course. Okay? All right, so let me summarize what we found here. If you have A times cosine omega t plus B times sine omega t, this can be put into C times cosine omega t minus alpha, where C is equal to square root of A squared plus B squared. And alpha, well, you can get it from this diagram, but here's a more efficient way to get it. See, it's like B is the sine and A is the cosine, right? So you can divide B sine over cosine and take the tangent inverse. So that's the formula for getting this angle alpha. However, the tangent inverse only produces values between 0 to negative pi over 2 to positive pi over 2. And often that's not what you want. You want to produce an angle between 0 to 2 pi or negative pi to positive pi, depending on your convention. Okay? So your alpha should be tan inverse of b over a plus some angle, extra angle theta, and that angle theta depends on where this a comma b falls in. So if your a comma b is over in the first quadrant, you don't have to add anything. It's just that. The tangent inverse works perfectly. But if your angle falls in the second quadrant, then this will give you a wrong answer. It will be off by a pi. So you have to add a pi. And again, in the third quadrant, it will be off by 180 degrees. And if you're in the fourth quadrant, you should add 2 pi because although you get the correct angle in this place, you get a negative value. Sometimes you want that to be positive, so you add 2 pi in order to get the coterminal angle to the original angle. Okay? So this is what you have to add in addition to using this form. This, by the way, was what you used to do when you're working with complex numbers, to go from a rectangular coordinate system to a polar coordinate system. To get the angle, you had to use a tangent inverse, but you also had to modify the tangent inverse value by certain values. Okay. So that's what you need. So that was the interlude. Let's go to a concrete example now. So example 1. Suppose C is 0, undamped, and the external force is 0. F of t is 0. So no external force, no damping, and you have a block of 4 kilograms is attached to a spring with spring constant, let's see, what's the spring constant? Newton meters, right? 1 Newton per meters. If the spring was compressed by 2 meters and was released, find period, amplitude, and phase angle of the motion. Okay. Okay, so what should I write down for the equation? Here's the solution. Where do we start? What's the equation?
The mx double prime.
Yeah. M is what? M is the mass. It's how heavy it is. Not heavy. Mass is not the same as weight, but it's the mass, right? So it's 4 x double prime. What is k?
1.
1. K is 1. C is 0. F is 0. So you have this. Now, what is x of 0? It also has initial condition, right? X of 0. What is it? compressing it, right? And then you're releasing it. Compressing it how much?
2 meters.
Yeah, 2 meters, so it should be negative 2. Okay, what about the initial velocity?
0.
0 because you released it, right? If I pushed it in one direction with some initial velocity, then it will be a different story, right? So this is the differential equation that you have to find. All you have to do is now find the derivative. Yeah, I shouldn't make it 0 because then the amplitude is too simple. Yeah, I'm sorry. Let's change the question. Was pushed. Was pushed. With let's just say 1 meters per second to the right. So because it's moving to the right, we should use positive 1 as the velocity. I'm sorry. I have to change this because if it's 0, then you only get one function, which is the cosine function. So there's no need to change it to the other one. Yes.
Our position doesn't change, right?
Yeah, the position is still, you compress it by 2 meters, and then while you compress it, then you push it that way with the initial velocity 1 meters per second that way. Okay. So in that case, how do you solve this? 4r squared plus 1 equal to 0. 4r squared is negative 1. R squared is negative 1/4. R is equal to plus minus 1/2 I, because square root of 4 is 2, and negative 1 has the square root of I. So that means your x is what? C1 cosine 1/2 t, C2 sine 1/2 t. This is a homogeneous equation. There's no need to find y particular or anything, so it's very easy. Okay. Now plug in the initial values. Negative 2 is x of 0. But according to this, what is x of 0? What's x of 0 here? C1, right? C1 is the only x of 0. C1 is the x of 0. Because if you put 0 here, cosine 0 is 1. If you plug in 0 into t, sine 0 is 0. So that gives you C1 equals to negative 2. Now what about x prime? X prime is 1/2 C1 cosine 1/2 t plus 1/2 C2 sine 1/2 t. And if I say x prime of 0, which is 1, this, oh, where did my derivative go? I'm sorry, it should be sine and, I forgot to differentiate. I applied the chain rule and forgot to differentiate. It should be sine with the minus, right? This will be cosine. Okay, then you plug in 0. Sine of 0 is 0, so that's gone. If you plug in 0 here, you get 1/2 C2, so that gives you C2 as 2. Okay, using all this, what's my value of C? Oh, first let's write down the solution, and let's apply that formula for changing it to a single function. Okay, so all this calculation says is that x is equal to negative 2 cosine 1/2 t plus 2 sine 1/2 t. That's what it says. All that calculation gave us this. Now we have to turn this into a single cosine. And to do that, we are supposed to use two formulas. C is equal to square root of -2 squared plus 2 squared, square root of, this is 4, that's 4, 4 plus 4 is 8, that's 2 radical 2, or 2.828 something. That's the value of your C. And then in order to get the angle alpha, first, where's -2, 2 located? -2, 2 is located here, right? So which quadrant? Second quadrant. So in this case, what do you have to add? Pi. 0, pi, pi, 2 pi, or 180 degrees. Okay, so let's do that. So angle alpha is tangent inverse of B over A, which is tangent inverse of -1. And you can certainly use your calculator to calculate this. If you calculate it, you're going to get -pi over 4 as your answer. And then you have to add a pi to each case because it belongs to the second quadrant. So you have to add pi, which becomes 3 pi over 4. And after getting your C, you can finally say that the answer to the question is x is equal to 2 radical 2 cosine 1/2 t minus alpha is 3 pi over 4. And from this example, you can say that the amplitude is what? 2 radical 2. Period is? It's 2 pi over the angular frequency, 1/2, right? So that's 4 pi. What's the phase angle? Minus alpha. Alpha is 3 pi over 4, right? So phase angle. This value that you got is called the phase angle. It's 3 pi over 4. So that's how you do the undamped case.